Welcome to Section 3 of the Pragmatic Developer's Scala Cookbook. This section is going to be about basic object-oriented Scala. We're going to cover a quick introduction to object-oriented Scala, then we're going to cover some additional trait features, and finally, we're going to cover singletons. Let's get started. A quick introduction to object-oriented Scala. It's going to be a little bit of a whirlwind, and we'll start by discussing creating classes and private instance variables. Then we'll discuss instance variable visibility, such as protected, and then we'll talk about def versus val versus var for instance elements. Then we'll talk about additional visibility modifiers like private package and private this. And lastly, we'll take a very quick look at abstract classes and using traits as interfaces. By the end of this section, you'll have covered all of the things that kind of let you use Scala classes in similar ways to how you would use classes in other languages, as well as a couple of very small extra tricks that Scala classes provide. Let's get to it. To define a Scala class, you use the class keyword. You follow it by the class name, typically capitalized, and then you define a constructor for it. In many other languages, constructors are defined separately, but in Scala, you declare the constructor directly as part of the class declaration. So in this case, we're giving this family a name and a list of the names of people in the family. When we declare this, we have a complete class. We can instantiate it directly. So if I said new family Salazar with two people in it, Antonio and Cleo, we would immediately have a family. We can't really get much out of this family. If I try to look at it, it's just the instance of this family object, or of this family class with a hash after it. So this is a class that has no special string representation or anything, but it does contain its values. Let's see really quick what would happen if we tried to get to the name. You'll notice that if you try to call .name on it, we get this error that name is not a member of this class. The reason that we get this error is because by default, the constructor parameters of a regular Scala class are not accessible outside of the class. If we wanted to make them accessible, we would have to give them an extra bit of information in front. So I could declare them as vals. This makes both of these instance variables accessible from the outside. It essentially makes them public. So let's look at now instantiating this family again, and then asking it for its name. This time we can fetch it normally. The same is true of the people names. We can actually include any sort of visibility modifiers that we want here as well. So if I wanted to declare that the people names are private, I could do it right here in the constructor. And now, if I instantiate the family, and I try to look up the name, it works. But if I try to look up the people names, we get a different error from when we couldn't find it. Here it is a member, but it cannot be accessed. So this is a pretty quick and easy and dirty way to create a class that's got some public and private state that is furnished from the outside as part of the constructor. Now what if we wanted to give this class the ability to have some internal state, something that it derives from the constructor parameters? Let's go back to having a family whose name and people names are not instance variables. They're just constructor parameters. But this time we want to provide access to a description. And that description is accessible as an instance method that returns a string. And to create it, we're going to combine the name, followed by a bracket, followed by the people names, joined by commas, followed by another bracket. Now we've got a new family class, and we'll go ahead and create the family the same way that we have before. And this time we'll call description on it. Now we see exactly the construction that we asked for. What about if we wanted this description to be private? We wanted this family to be a container for all this information, but want none of it to be accessible. We can change this def to be private just by putting private in front of it, as you would expect. Once we run it, we instantiate the class again. This time if we call description, we will get again that it cannot be accessed. Pretty straightforward. Now, one interesting thing to note here is that this is a def, and there's actually a very specific difference between a def and a val, and one type of declaration that we haven't discussed yet, which is the var. Let's say we wanted to create a family that kept track of how many times description was called. We'd make description public again. We'd have these guys be constructor parameters, plain and simple. But in order to increment each time that description is called, we'd need a private var. And we'd call it description calls. It would be an int, and it would start at 0. Description calls is a var because we want to update it. We want to be able to change it. Var means that we're creating a mutable variable that we'll be able to change over time within the same instance of the family. Then we create description. This time we'll make it public. And we will do two things in here. The first one is we'll take description calls and add 1 to it. And the second thing is that we will return the name followed by a bracket, followed by the people names, joined by a comma, followed by another bracket, and then we'll go ahead and include the description calls. Count. So now let's create a new family again, and we'll call description on it. We see that description calls is now 1. Keep in mind we increment it before we create the string, so even though it starts at 0 the first time we create the string, it is already 1. It has already had 1 added to it. Then we'll call it again. Now the value is 2. Then we'll call it again. Now the value is 3. Let's say we change this def to a val. This is still public, so when we create a new family, it'll still be accessible. We'll still be able to call description. The first call, it'll still be 1. The second call, it remains 1. When we declare it as a val, the content here is initialized when the class is instantiated. So description calls starts at 0, then we evaluate description, increment description calls once, create this string once, and then every time we call it after this number is the same because this whole string is the same, because we only ever run this code once. It gets stashed in this immutable variable, and then in the future we just refer over and over again to that already constructed value. So we've seen what val is, we've seen what var is, we've seen what def is, and we've also looked at how these call each other and how you can declare something private versus public. Public is the default for any val and any var that's declared inside the body of a class, and not being an instance variable at all is the default for constructor parameters. So if you want them to be instance variables, you have to explicitly put a val in front of them or var in front of them. You have to then control the visibility manually by putting private or what have you in front of that. Let's talk about creating a class that extends our family class. We'll call this one modern family. It takes the same 2 parameters. We want it to share some of the behavior that the family class has. So we'll say it extends family. And when we declare that it extends family, family has this constructor that we have to call that takes the name and people names. And when we extend it, we can call it directly. We can say, I'm going to pass the name that's passed to this constructor directly to the family constructor, and the people names passed to this constructor also directly to the family constructor. Then modern family is going to have a modern description, and the modern description is going to take the description and it's going to replace all of the e's with 3's. Now we'll go ahead and create the modern family with the same parameters that we had before. Salazar, Antonio, and Cleo. Then we'll call on this modern family description. Just like before, this is the exact same string, and if we call it again, it remains unchanged. This is still a val because we extended this version of family. If we try to call the modern description, now we'll see this same string except we've replaced the 1e with a 3. If we call it again, this remains unchanged. Even though modern description is a def, which means that we run this code every time, the description, the original description, is still a val. So we still reuse the original value of description. And each time we call modern description, we just replace, we look up that original value, replace all its e's with 3's. Not the most efficient move, but that's fine. So now we've got this modern family maybe we want to abolish the ability to create the original families. We're going to take the original family class and make it an abstract class. All we do is put this abstract keyword up here, and we'll also make description protected. Protected means the only people who can access the description value will be subclasses of family. The abstract family works the same way as the regular family, except we can no longer instantiate it directly. Now if we try to do that, we get class family is abstract, cannot be instantiated. So let's redeclare the modern family. It'll extend this new abstract family, and we'll reinstantiate the modern family. Now if we try to call description on the modern family, we will get, once again, that it cannot be accessed, because the access to the protected value is not permitted since we're not working in a subclass. If we were trying to access description in here, we would expect it to work. So let's try doing res32.modern description. There we go. We can access it perfectly normally because modern description is public, not protected. Two more things I want to talk about before we get into traits. The most basic one is the fact that we have some more powerful visibility modifiers in Scala. We're not going to experiment with the actual outcomes of them here, but suffice it to say that I can declare a variable here, or a def or what have you, that is defined as private this. Private this is a little more stringent than private by itself is. Private this means if some other instance of modern family tries to access thing, it won't be able to. Private typically means no other class has access to a variable. Private this means no other instance has access to this variable. It's a subtle distinction. For the most part, you don't really need to worry about that distinction, but you should default to private this if possible, just because it is the most restricted form of visibility. And it's always better to be as restrictive as possible and loosen your restrictions only when you know that you explicitly want to. That's usually a safe tenet to follow when you're doing your class design. The other type of modifier that we can have here is these brackets take more than just the this keyword. You can actually put a package name in here. The package name limits the access to this variable to any class that is inside the same package as this class. This is something that you might want to do if you have a package that's providing some relatively complex functionality that can benefit, for whatever reason, from direct access to the typically private state inside other classes in the package, but you don't want to expose that to people who are using your package. This is occasionally used when building Scala libraries. It's not quite as common when you're building, just an application, but it can be a useful way to share state without making it visible to everybody, basically. You can share it just with other classes in your package. With that, we'll look at one more little example here, which is to do with traits. We're going to declare a trait nameable, and that trait is going to declare that it has one def called name that returns a string. Now the interesting thing about this is actually satisfied by anyone who has a name val. So if we redeclare our modern family to extend family and also mix in nameable, so we can say it extends family and it is also nameable by typing with nameable. If we run this, you see class modern family needs to be abstract because the method name in the trait nameable is not defined. Now we have a name here, but it's not a variable and it's not a def. So how can we fix this? The answer is we can actually just change this to a val. And then when we run it, it works perfectly. That's because a val behind the scenes creates a private instance variable called name, but it also automatically creates an accessor method, also called name. So, in point of fact, the instance variable is named something slightly different. But val name string satisfies the requirement that there be a def name that returns a string in this nameable trait. We can also declare a person. They also have a name, they also have an age, and it extends nameable. Now remember, this will fail to compile because there is no method name defined. We need to make this guy a val. Now we have a person. Let's create one. And this person has a name. And we have a modern family. Has a name. Now the interesting thing is we can now use nameable as an interface. So we can consider nameable to be an interface that specifies that it has one method, name, and that method returns a string. So we can declare my nameable as a type nameable and put res41 in there. And my nameable can be named. And we can also declare one that has res43 in there. And my nameable now can also be named. So we can put a modern family in there or a person. One interesting thing to note, a side effect of the fact that vals satisfy def. Most traits should deal exclusively in defs. You should almost never specify in your trait that you want an implementing class to have a val. That's because if you define it as a def, you give the implementer flexibility as to whether they want to compute something once or compute it on demand, or compute it multiple times every time that it's invoked. So making the requirement be a def gives the implementer maximum flexibility on how exactly they want to implement it, be it for performance reasons, parallelism reasons, or whatever else. That's all we're going to look at in the basic object-oriented round this intro.